Under the emergency lights, the control room at NASA suddenly lit up in red. A distinct alert, one unlike any other, had just been triggered. The system that monitors celestial threats had flagged not merely a random rock, but also indicated an object on a perilous intercept path. This object was 3I Atlas, an interstellar entity racing toward the moon of Earth. Observations confirmed a dire situation. NASA declared a Level 2 emergency, a classification reserved for genuine threats capable of colliding with a celestial body. Sources tracking asteroids reveal that such alerts arise only when the odds, while small, indicate significant peril. At this juncture, scientists are confronted with a chilling question. If 3I Atlas strikes the moon, what repercussions will follow for the moon's surface? The satellites in orbit around Earth, and even for us here on Earth? Everything once seen as stable and secure suddenly feels precarious, as humanity's deepest fear shifts from the distant stars to the silent object accelerating toward our satellite. Stay tuned, as what transpires next is sure to astonish you. If you find the enigma of 3I Atlas captivating and wish to explore more marvelous cosmic tales, hit the like button to signal your interest to the universe. Every click counts. Help keep the quest for the unknown thriving. Leave a comment below and share where you're watching this video from. I'd love to know which corners of the globe are joining me for this moment. Preliminary data from NASA validated the object, designated 3I Atlas, as the third recorded interstellar visitor. Following Oumuamua in 2017 and 2I Borisov in 2019, however, unlike previous benign travelers, 3I Atlas did not pass quietly through the solar system. Instead, it barreled into the moon's gravitational field at speeds exceeding 150 miles per hour. Enough to traverse the Earth-Moon distance in just a few hours. Within minutes, NASA's impact simulations were running non-stop, each update heightening the alarm. The results indicated a potential impact crater measuring 1,218 miles wide, and an explosion bright enough to be visible with the naked eye from the skies over Washington. The Planetary Defense Coordination Office swiftly declared a state of emergency. NASA, ESA, and JAXA activated round-the-clock synchronized monitoring, tracking every orbital wobble and minute change in light intensity, all logged in real time, as if bracing for an extraordinary event. The prospect of humanity witnessing the first collision between an interstellar object and the moon has transformed what was once merely an academic inquiry into a global obsession. Harvard astrophysicist Avi Loeb, who has questioned conventional theories surrounding Oumuamua, has begun to scrutinize 3I Atlas with unusual wariness. His team has observed that the object's motion appears exceptionally stable, with a precision surpassing that of any known natural comet. While Loeb has refrained from making definitive claims, his earlier studies have suggested that not all interstellar travelers are heedless. Meanwhile, experts at NASA's Jet Propulsion Laboratory encountered an inexplicable paradox. The flight path of 3I Atlas showed little impact from solar wind or radiation pressure, behaving as if guided by an invisible mechanism. The debate intensified. Was this a rare scientific opportunity or a herald of a cosmic catastrophe humanity couldn't avert? Should the moon endure a collision, tidal models predict small yet measurable changes in Earth's rotational stability, potentially disrupting tidal rhythms and orbital resonances. Not enough to obliterate the moon, but enough to disturb the delicate balance that has sustained life for eons. As telescopes worldwide focused on the approaching light, an eerie hush fell over mission control. No rockets were set to launch, no means to intervene. All that remained was to observe, wait, and count down the seconds, not to prevent collision, but to witness what the universe would unveil next. As new readings trickled into NASA mission control, the orbit of 3I Atlas began to warp in unforeseen ways. The interstellar object was no longer following a stable trajectory, but had begun a silent curve southward, tilting toward the moon's lower hemisphere. Initially, the drift was slight, but each update narrowed the safety margin, revealing a trend that was anything but random. Simulations indicated that if it drifted a mere fraction of a degree, 3I Atlas would enter the moon's gravitational grip, pulling it down to the surface at speeds surpassing 70,000 miles per hour. Escape would be nearly impossible. If this trend persisted, a collision could materialize in less than 3 weeks. At Goddard Space Flight Center, thousands of Monte Carlo simulations reflected a diminishing probability of safety as the scenario unfolded in real time. Observatories around the globe confirmed that the object was speeding toward the moon's south pole, close to Shackleton Crater, where ancient ice deposits are suspected to exist. A collision there could eject a column of dust hundreds of miles into the sky, altering the moon's color and brightness for months on end. Avi Loeb and his team continued to analyze the unusual behavior of 3I Atlas. Unlike typical comets, it remained stable and adjusted its trajectory in response to weak, symmetrical gas flares detected by the ESA solar probe. This prompted debate at the Jet Propulsion Laboratory, where some experts contended it was merely a natural outgassing, while others argued that the precision of the maneuvers perfectly aligned with gravitational windows, resembling a navigational signal. By week's end, the impact corridor had slimmed to under 200 miles, marking the smallest uncertainty ever logged for an interstellar object. An engineer asserted that if 3I Atlas were to shift by just 1 degree, humanity would witness the first interstellar collision in history. The haunting question for scientists now revolved not solely around gravity, but whether a guiding force was directing the orbit. At Goddard, energy analyses painted a harrowing picture. The collision could unleash energy equivalent to hundreds of megatons of TNT, 10 times more potent than the Tsar Bomba. Without an atmosphere to absorb the impact, all that energy would crash into the moon's surface, generating seismic waves that would ripple to its core. A crater nearly 20 miles across would form, blasting billions of tons of dust into space, creating a halo that could encircle the moon for hours or even days. The explosion's light was forecasted to be bright enough to be spotted with the naked eye from any continent, even during the daytime. While the spectacle promised to be breathtaking, the Planetary Defense Coordination Office cautioned that the dust cloud could alter the moon's reflectivity for months or years, disrupting tidal patterns and Earth's rotation. Oceanographers anticipated stronger coastal waves, while climate scientists expressed concerns that diminished moonlight might affect nocturnal ecosystems and long-standing atmospheric cycles. Yet, social media buzzed with the phrase "second moon," accompanied by simulated images depicting the sky aglow following the impact. While the public was captivated by this intriguing potential, engineers in Pasadena remained fixated on the ever-rising probability curve. A scientist reminded the control team that the light from the impact would take 13 seconds to reach Earth. And by the time it did, it could all be over. As the countdown edged toward zero, stillness enveloped observatories worldwide. For the first time, humanity was on the cusp of witnessing the universe in motion. Not as an abstract notion, but as a tangible force capable of shaking the heavens and the world beneath. As the potential impact point approached, scientists began to worry that the gravest threat lay not in what could be seen, but in the unseen repercussions. NASA's seismic resonance models indicated that should 3I Atlas strike the moon, shockwaves could cause the entire satellite to vibrate for hours, creating a moon chime effect. This phenomenon was first recorded in 1969, when the Apollo 12 rocket stage crashed into the moon, resulting in vibrations that lasted close to an hour. This time, experts warned that the impact could be thousands of times more intense. The Apollo seismic network, still operational due to modern telemetry, would be crucial in gathering data that might unveil structures deep within the moon that probes and radar have never been able to penetrate. However, if the impact occurred on the far side of the Earth, some researchers cautioned against the potential for weak seismic resonances to transmit back to our planet. Minor shifts in the moon's mass distribution could influence its rotation and tidal cycles. The Goddard Institute for Space Studies confirmed that, in theory, this chain of events could have long-lasting effects, altering ocean tides, changing the length of a day, or disrupting the orbital synchronization that stabilizes Earth's axis. Even the slightest variations in the moon's behavior could affect high tide timings and the migratory patterns of marine life. According to NASA, Climatologists estimated that a mere 0.1 shift in Earth's tilt could warp seasonal rainfall patterns, while extending the day by mere seconds could disrupt atmospheric currents. The moon's stability, which underpins life's natural rhythms, was at stake. The atmosphere in the command center became tense. The question was no longer how much the moon could withstand, but what Earth could endure if its sole satellite were thrust off balance. As one geophysicist noted in a late-night report, "We've spent centuries observing the moon's light, and now we're about to experience its internal vibrations echoing back to Earth." As 3I Atlas approached, NASA and other prominent space agencies were compelled to confront an uncomfortable truth. Our planetary defense system possesses such significant blind spots that an interstellar object could sweep through our solar system almost unnoticed. The Atlas network, designed to detect asteroids within our own solar system, identified 3I Atlas only after it had already crossed the boundary of our neighborhood and entered this solar system. Too late for intervention. Leaked internal reports from the Planetary Defense Coordination Office reveal that the current warning system relies solely on predictable orbits, which has proven inadequate for monitoring super-speedy interstellar objects. 3I Atlas slipped through a loophole that humanity never imagined could exist. As international media erupted, hearings and debates ignited. EASA contended that the responsibility of monitoring shouldn't rest on a single nation, while JAXA advocated for a global early warning alliance, prompting China to discreetly expand its own observation initiative. Nevertheless, the countdown marched on. In Geneva, during an emergency United Nations session, a Brazilian delegate posed a question that silenced the entire assembly. If the target was not the moon but Earth, would we have detected it in time? This inquiry quickly became the centerpiece of every news report. Meanwhile, NASA's simulation team devised a scenario where the orbit deviated merely 1% toward Earth. The impact would unleash energy equivalent to 10,000 nuclear warheads, enough to incinerate the upper atmosphere, spawning a debris cloud enveloping the globe, significantly diminishing sunlight and throwing weather into disarray. Scientists likened it to the Chicxulub event that annihilated the dinosaurs. But this time, humanity was aware and helpless. Within scientific circles, the message spread rapidly. 3I Atlas not only represented a rare phenomenon, but also served as a warning about the vulnerability of humanity's understanding of the universe. Discussions emerged surrounding plans for a new generation of wide-field observation sensors, yet NASA's roadmap indicated it would take years to develop and deploy. For the present, Earth remains reliant on the existing warning network, with scientists able only to watch as the data continues rolling in on their screens. One researcher succinctly captured the situation with a chilling remark. "We are learning the hardest lesson. The only way we can is by watching it happen in silence." As the moment with 3I Atlas neared, the world found itself divided into two opposing factions. One side believed this was the greatest scientific opportunity in human history, a unique chance to observe a planetary-scale collision directly. The other warned that this could be the precursor to a cosmic catastrophe, an event humanity was not equipped to handle. At observatories from Hawaii to Chile to the Canary Islands, telescopes were running continuously, transmitting terabytes of data every hour. Each spectral variation and every unusual flash of light was meticulously analyzed and archived, with the hope that years from now, humanity would possess enough information to comprehend the underlying forces driving the behavior of an interstellar object. In the final moments before impact within NASA, the divide widened further. Astrophysicists viewed this as an unparalleled opportunity, arguing that no simulation, no matter how sophisticated, could replace direct observation of a lunar-scale impact. "We've modeled these events for decades and have never truly witnessed one," one researcher stated in an interview with Nature. "This moment could rewrite our entire understanding of impact physics." Conversely, systems engineers and planetary defense specialists cautioned that the risks were being underestimated. Their models indicated that even a minor offset could disrupt the moon's orbital stability, or incite a massive dust storm that could significantly diminish sunlight reaching Earth. During a tense internal meeting, a senior NASA analyst bluntly remarked, "We're acting as observational scientists, but we're standing right under the hammer." As the clock ticks away, the scientific debate transitions into a matter of survival, forcing the world to wait and see whether 3I Atlas will signify a turning point in knowledge or serve as a final cosmic warning to humanity. Amid escalating tensions, the private sector has entered the fray. SpaceX and Blue Origin received urgent requests from NASA and ESA to prepare robotic probes capable of reaching the lunar South Pole before the anticipated impact. The objective is to directly observe from the surface, gathering data that satellites cannot provide. However, the plan quickly raises concerns. Could the launch interfere with the trajectory of debris? And will the probes arrive in time? On social media, the discussions ran rampant. Some advocated for the use of boosters or nuclear measures to divert 3I Atlas in the DART model. Many scientists opposed these ideas, arguing any intervention could sabotage the most invaluable natural experiment in history. Religious and philosophical debates also surged, turning 3I Atlas into a symbol of both fear and faith. During a panel discussion, a planetary scientist commented, "The universe is conducting its own experiment. In this time, we are both spectators and subjects." As the green glow of 3I Atlas became clearer in lunar orbit, the world held its breath. Some prayed, others checked their equipment. Then something unexpected occurred. NASA abruptly halted all updates. The live data website froze, and press conferences were postponed without explanation, leaving the world baffled by the sudden silence. Independent astronomers quickly stepped in. By comparing their data with historical records, they discovered that 3I Atlas exhibited unusual brightness fluctuations near the Moon's south pole. Notably, the object seemed to periodically decelerate and then accelerate, behavior that contradicts that of a natural comet. Within the Jet Propulsion Laboratory, insiders reported a palpable atmosphere of unease. An anonymous engineer informed the Washington Post that the observed energy spikes could not be attributed solely to gravity. The object appeared to be adjusting its velocity. If true, 3I Atlas no longer resembled just an interstellar rock. Rather, it seemed like a craft actively navigating its own path. According to leaked minutes from an Aerospace Intelligence Agency meeting, multiple senior scientists reportedly briefed the Pentagon and the White House privately. Discussions revolved around whether to categorize the event as a national security anomaly. Some speculated that releasing complete data could incite panic, while others argued that remaining silent would only fuel conspiracy theories circulating online. And they were correct. On platforms like Reddit, X, and TikTok, amateur astronomers shared real-time observations suggesting that the light fluctuations were too precise to be mere randomness. Theories flourished, proposing that 3I Atlas could be a probe, a piece of alien technology, or even something reacting to human observation itself. A small yet vocal contingent of scientists began questioning NASA's reticence. Avi Loeb remarked to The Hill, "If there's even a 1% chance that this object isn't natural, we have a duty to study it transparently. Concealing data doesn't safeguard anyone. It delays understanding." Meanwhile, European and Japanese observatories reported similar anomalies but refrained from public confirmation, resorting to encrypted internal channels for updates before falling silent. Then, on the night of October 28th, the day before the expected impact, the Lunar Reconnaissance Orbiter transmitted inexplicable images, showing a faint pulsating light trailing behind 3I Atlas, expanding and contracting as though it were breathing. Within hours, the image vanished from NASA's servers, with officials claiming it was merely a data compression error, a statement few believed. As the world gazed at the dark side of the moon, awaiting the moment of truth, one question resonated more loudly than any news headline. Was NASA tracking a comet in free fall, or were they concealing something humanity would never learn? As the moment drew closer, the world held its breath. Billions of eyes turned skyward, seeking any flash, anything to affirm what they feared or hoped was real. For several endless seconds, the moon remained silent, pale and motionless, as if the universe itself awaited a decision on what would come next. No one could predict whether they were on the brink of witnessing catastrophe or revelation. Some anticipated a blinding explosion, others feared they might see nothing at all, with the real impact manifesting quietly in data and memory. Yet in that collective stillness, a transformation occurred. Humanity, with all its instruments and equations, found itself humbled once again before the universe's unknowns. The moon became a mirror, reflecting not just the sun's light, but also our deepest human fears. That while we can observe the universe unfold, we cannot control it. The saga of Three-Eye Atlas transcends mere science or danger. It now carries a perspective on awareness, highlighting how small and temporary our control truly is. Regardless of whether it collides or passes by, the lesson remains constant. Three-Eye Atlas serves as a reminder that the sky we perceive can shift in an instant, and that knowledge itself teeters on the brink of fear. Perhaps the universe is not delivering destruction but a warning, or even an invitation to take a closer look next time. So, do you believe Three-Eye Atlas is a natural event orchestrated by the universe? Or is it something sent to observe us? Share your thoughts below and subscribe, for what follows could alter the way we perceive the sky forever. Until next time.